If you're new to this channel, you may consider subscribing and hit the bell icon so that you continue to receive the updates. Also, after watching this video, you may want to refer to some of the playlists that we have created for people who are interested in in-depth knowledge. These are the videos in the right sequence, which will give you thorough knowledge of the subject. Please share it with all others who might benefit. Let's get started. So now we begin with lemmatization on the text that has already been pre-processed to some extent, and we will use WordNet Lemmatizer. Please note, we've discussed stemming also, but the problem with stemming is that it may lead the word to a non-dictionary form, and if you want to interpret the outcome, it may not be fruitful. So we are choosing lemmatization. If you want, you can also apply stemmer. Again, you have multiple choices when it comes to stemmers. So we are again importing the WordNet Lemmatizer here from the NLTK library, and we are instantiating the Lemmatizer. Now, Lemmatizer again works on the tokens. So what we are doing is, for each word in word tokenize X. Why are we tokenizing? Just some time back, we joined everything back. So we are tokenizing it again. And we are saying we'll take each unit of the tokenized state of the review text and apply the lemmatization to it. Now, what we can do is we can do a quick comparison between the original text as we read to begin with and the processed text so far. So what we are creating is a comparison data frame which concatenates review text feature from the original state versus the state where we are right now. And we are just looking at the outcome of 7 randomly selected observations. So if you see, this was the original text, and this is the output that we have, right? So a few places you may find that some of these words have been kind of merged or they're kind of overlapping because a lot of text would have been cleaned. But overall, looking at the large corpus, it would not make much of a difference to the analysis. Some of the words, if you can see, the ... here got eliminated, and it's kind of merging some words. But other than that, if you see, everything has been converted to lowercase and all the punctuations, etc. have clearly been removed. Next, we will create a word cloud. So we already know that our text has 2 categories. First is the set of customers who have not recommended the product, and that's something which is represented as 0. And the second is the category which has recommended the product. So we'd want to see if there is a contrast that we are able to see between them, or is there any difference between the 2 word clouds. Now, we've discussed word cloud earlier as well. Word cloud is just a kind of count representation. It, based on the frequency, assigns the font size to the words. So we will try to create a word cloud. We filtered the data as per the recommendation 0 and recommendation 1, and we are joining all the text within the review text column, and we are trying to create the word cloud. And all of this is being done on the text that's already been processed. And a couple of inputs for the word cloud. So we're giving some width and height inputs and choosing the background color. This dot generate requires the text input, which has been processed. And that's what we're passing here. And the same kind of code for the recommendation status 1. We're just trying to put them side by side using matplotlib's plt.subplot. So first would be the word cloud for recommendation 0. We don't want any axes there because it's just a word cloud. We don't want X or Y ticks. And same is the case for the recommendation status 1. Let's run both the lines of code and see what's the outcome like. So it doesn't show a very stark contrast between the 2 categories. For example, the people who have not recommended the product, they don't seem to have given a very negative feedback overall. So you don't see negative words. But of course, you see a larger emphasis given to some positive words in the scenarios where the customer has recommended the product. For example, love that you see here is a much bigger font size compared to what you see here. It's a much smaller font size, right? And similarly, you could see some other words like perfect, flattering, great. These are somewhat more emphasized when the customer has recommended the product to someone. So that's an overview. Yes, it of course depends on the quality of the data and the kind of contrast that data has to begin with. If there would have been a lot of negative words for cases where people have not recommended a product, you would have seen those words occurring here more frequently and with a larger font size. But in our case, it looks like you don't have such a stark difference. You have some difference, and that's why some positive words get highlighted. This top is a clothing item, so don't consider it top as something positive. It's about women clothing, so this is the name of a clothing item here. All right, so now we are at the modeling stage, and we are going to do the usual stuff, which is that we're going to separate the X and Y variables. X, in our case, would be just the review text column. Of course, we could have taken other features like age and ratings and other categorical features as well. But for this example, we chose to work only on the review text feature as the predictors, and the Y variable, of course, is very clear. So we are doing the train test split, parking about 20% of the data as test, and the remaining data, of course, would be a part of the train. So let's run this. This gives the split. And one of the classic models that has been very popular for the text-related tasks before deep learning, of course, was naive Bayes. Now, we are using a variant of naive Bayes, which is the multinomial naive Bayes. Why? Because we have word frequencies, which are not just binaries. So we are not using the typical naive Bayes. We are using the multinomial naive Bayes. And we are using a count vectorizer to first bring our data to a vectorized form. So the count vectorizer is being called, and we are doing a fit transform on train and just the transform on test. And then we are instantiating the multinomial naive Bayes algorithm. We are doing a fit on the X train vectorized and Y train, which are the labels. And then we are making predictions on both train and test set. So what we're doing is we are doing a predict on X train vectorized. We are predicting on X test vectorized. This would give us Y pred train and Y pred test respectively. And we are going to use them in our classification report. So we'll just run this and quickly do a comparison between the train and test performance in this case. So it looks like in our training, our identification of ones is pretty good, 97%. This is the recall, and our precision is 95%. So as far as class label 1 is concerned, which talks about the fact that the customer has recommended the product, that has been identified pretty well. If we talk about class label 0, when the customer has not recommended, the recall is 76% and precision is 84%. However, if we look at the test performance, whenever we have a case of recommendation as 1, we seem to be pretty consistent. It's more or less matching. Recall is 97 versus a 96 here, 95 versus an 89, which is decent. We seem to have a bit of an issue with the recall here when it comes to the class 0, which is when the customer has not recommended. And if you remember, we had some amount of imbalance as well. So we can try multiple options. We can try different models. We can try treating the imbalance. And of course, we can use additional features. But since the primary objective of this exercise was not to come up with the most accurate model, it was to use the text data to make predictions. So I hope you've seen that here. And in future, when we'll take up more examples, we will talk about fine-tuning these models as well. But now that's pretty much about this case study. Thank you.